Hello, good morning. Welcome to the third day of the conference. It is an enormous pleasure and a great honor to introduce Nick Ellis. And I've been thinking about how to introduce Nick to an assembly of cognitive linguists. And I thought cognitive linguists know all about categorization, so I'll give you some categories that Nick belonged to. So starting with very broad categories, I think you can divide researchers broadly into two main categories, what I call visionaries and truth seekers. So visionaries are people who have these incredibly interesting, fascinating ideas, these castles in the air, very, very exciting. And truth seekers are people who actually want to, you usually end up pulling those castles down because they are interested in the world in its complexity. And so those are the two main categories. And then there's Nick Ellis. So his research is, he's a person who combines these two qualities. He has big visionary ideas, but he's also interested in the world in all of its complexity. And I think if you look at his institutional affiliation, that also shows you how difficult he is to classify. So is he a psychologist or a linguist? Well, he's a professor of psychologist and professor of linguistics at the University of Michigan. He's also, not just, that wouldn't be enough for Nick, he's also an associate of the Center for the Study of Complex Systems and a research scientist at the English Language Institute. Oh, and somehow, when he's got a free minute or two, he's general editor of Language Learning. I don't know how he does all this, but somehow he manages. Previously, he worked at the Open University, University College of North Wales, Reading, Bangor, and he has had visiting professorships all over the world. I won't even mention the places. And I'll just read you from his webpage some of his research interests, just a few, okay, not the whole list because that would be too long. So here it comes. Second and foreign language acquisition, corpus linguistics, psycholinguistics, applied linguistics, emergentism, dynamic systems and complex system approaches to language, reading and spelling acquisition in different languages, computational modeling, cognitive linguistics. Just not much, right? Anyway, so Nick is the person who combines insights from lots of different disciplines. He uses a number of different methods in his research, and I think that's what makes it interesting. It's so interesting, it's the fact that it's so multifaceted. Today he will be talking to us about usage-based approaches to language acquisition and processing, which is, I know, an interest of his that he's been working in this area for a very long time. Last year, he published a book co-authored with Ute Rome and Mike O'Donnell with this title. So I think we'll find out a little bit about what's in the book and probably some other things that didn't make it into the book. He's also the author of about 200 articles as well. He's also managed to edit several very useful handbooks in various areas of linguistics. I won't even mention them. I think rather than attempting to talk about Nick, I'll give the floor to him, to the visionary truth seeker, Nick Ellis.
Thank you, Eva. Eva, that was lovely. Thank you very much. Far too kind, far too kind. Thank you all for turning up this morning. I am today going to talk about usage-based approaches to language acquisition, and language processing. I'm a psychologist, and I started out being interested in reading and spelling acquisition, developmental dyslexia, and I was lucky to live through the connectionist revolution, the time when people recognized that the psychology of learning was intimately tuned to our experiences over our lifetime. I then got interested in second language acquisition in the early 90s and went to a few second language acquisition conferences. I was living in Wales, I was interested in language learning in adulthood, and I recognized that there wasn't very much psychology research in this area. Let me begin, though, with a picture and a poem. Always a good place to start, I think. My favourite picture, as far as language is concerned, my favourite image, is de Saussure's thought sound. That there is stuff going on out here, and the patterns in the stuff out here affect what we think. Yeah? There are waves of sound activity, and somehow, magically, they affect our thinking, and we can communicate through them. That's my favorite picture. This is my favorite poem. It's from Walt Whitman. It's from a wonderful, long poem called The Song of Myself. And at some point in it, he reflects on the people that he knows in the world. And he talks about the fisherman and the woodsman and the young bride and the old man. And he thinks about all of these people that he knows and the things that they do. And having described each of them, he says, "And these tend inward to me, and I tend outward to them. And such as it is to be one of these, more or less I am. And of these one and all, I weave the song of myself." And what he's doing, I think, is he's talking about, who am I? I am the sum of all of my interactions with all of the people I have known in my life. Yeah? From that mass, from that conspiracy of experiences, that is me. And I think a usage-based approach to language is exactly that. That I have been exposed throughout my life to a whole variety of meaningful conversations with other people, and there are different patterns in what's going on out there, and they have affected what I think in here, and my language capability emerges from the history of all of the language experiences that I've been involved with. So, it's great to be here. My first ICLC was in 1997. So there I was looking for theories of language acquisition as I got into second language acquisition. And I was going to second language conferences, applied linguistics conferences, generative linguistics conferences, and I was searching around for a theory of language that made sense to me as a psychologist. And I landed at ICLC and I felt at home. And so over the years, I have been much impressed with the society because of its diversity of backgrounds and approaches, but because of some general sort of tenets which somehow make sense to me as a psychologist in learning about the world and learning about language. So, thank you for having me. 20 years later, it is a great honor to be standing up here and speaking to you. So, what are the central ideas that many of us in this room share? Well, I came into it as a psycholinguist in that connectionist statistical learning revolution. And what I recognized was that the study of psycholinguistics was 30 or 40 years of demonstrating that language processing is sensitive to frequency of usage. That we process more easily high-frequency forms over low-frequency forms. That we process more easily regular forms, which are high-frequency, high-type frequency forms, yeah? More readily than irregular forms. And we do it for spoken word recognition, or naming, or reading, or processing of individual letters, or bigram sequences, or trigram sequences, or spelling to sound mappings, or understanding sentences. Whatever area of language you look at, psycholinguistics says that language processing is sensitive to frequency. It's 40 or 50 years demonstrating that, thousands of studies. Now, what does that mean? It means that each episode of processing affects the learner's system. If we're sensitive to frequency, if we're sensitive in our processing to the frequency of things, well, we haven't got frequency from a dictionary. We've got frequency from a mass of experiences over our lifetime, of processing these high-frequency forms rather than these low-frequency forms. I think that psycholinguistics demonstrations of the sensitivity of language processing to frequency tells us that learning is usage-based. Give or take a bit, but generally that's what it tells us. And so acquisition models which ignore usage distributions are missing something important. Yep. What we really need to know if we're learning over usage is what is the acquisition environment, what is the problem space. We ought to be looking at the language acquisition environment. Yep. We ought to be looking at the history of language events which I've been exposed to, you've been exposed to sort out what abstractions I have made from that experience, what abstractions you have made from that experience, and what is it that allows us, therefore, to communicate like this. And the same is true for acquisition, for processing. We just need to look at those usage distributions. And so, my broad approach, I think shared with many in the room, is that of usage-based grammar, cognitive linguistics, the notion that we learn constructions. We learn patterns in the sound out there which correspond to meanings inside heads. And so we might take a construction grammar notion that the units of language are constructions, form meaning mappings, conventionalized in the speech community, experienced a lot, and therefore entrenched as language knowledge in the learner's mind. So usage-based acquisition, we learn constructions through using language. We're learning about language right now. Yeah? Every experience of language reinforces the system, tunes the system. And creative linguistic competence emerges from the collaboration of the memories of all of the utterances in a learner's entire history of language use, and then frequency-biased abstraction of the regularities within those experiences. So we're sharing some these ideas are shared across cognitive linguistics, functional linguistics, psycholinguistics, corpus linguistics. And I think we can all agree that it doesn't make sense to separate grammar from lexis. Every word has its own local grammar. It doesn't make sense to separate form from meaning. It doesn't make sense to separate meaning from context. It doesn't make sense to separate structure from usage. Yep. These things influence each other. Language is an emergent, complex, adaptive system. You can look for patterns within any one of those domains, but when you try and work out how did these patterns come about, they came about through those dynamic interplays through the history of usage. So, I'm interested in the learning of constructions. I'm a psycholinguist, a psychologist, and I might think about different types of construction. I might think about this lexical construction.
Today.
Something out there in the sound environment which cues a particular interpretation. But I'm a psychologist. And so I'm informed by the psychology of learning. I need to try and sort out what are the things which make this as a construction learnable, and this is a construction more or less learnable than other constructions. And so we can go to the psychology of learning. It has a rich tradition. We know a lot about the psychology of learning, and we might go to the usual suspects for driving forces of learning. And some of those usual suspects are the frequency with which we have experienced that particular sound pattern, the frequency with which we have had that particular interpretation, the degree to which that particular interpretation is a prototypical, central meaning, or one which is rather more peripheral. So the frequency of the form, the frequency of the meaning, the contingency of the form and the meaning, the degree to which that form is reliably associated with that particular interpretation, the salience of that particular sound pattern, the salience of this particular interpretation. All of these things are going to be important. And there's a rich study of the psychology of vocabulary acquisition, or the applied linguistics of vocabulary acquisition, which shows these to be important factors. There are other usual suspects that we might worry about. Redundancy, overshadowing, some basic animal learning, human learning phenomena, which I'm not going to refer to much today. The importance of attention, both in humans and animals, the central importance of attention in all of these things. And attention which often is cued in social interaction. And shared theory of mind and cooperation and collaboration, where one speaker talks to another speaker and cues interpretations. And in second language acquisition, the importance of transfer from one language to another, blocking, interference effects, what I call learned attention effects. And I've done a lot of work on learned attention, but I'm not going to be talking about it today. Incidentally, if anybody's interested in papers or the slides from this, just drop me an email and I'm very happy to share them. So that's one type of construction. There is a rich psychology of the learning of vocabulary. This is another type of construction. That at the end of some words. Now there are those sounds at the end of a lot of different words in English, but when it's at the end of certain words in English, it means certain, it gives certain interpretations. When it's at the end of a verb, then it has a particular interpretation, third person singular, simple present tense. And when we're thinking about the learnability of morphosyntax, particularly in second language acquisition rather than first language acquisition, we know that that's hard. We know that the basic variety of second language acquisition is typically light in morphosyntax, light in grammatical functors, and we might ask why. Well, I think there's a lot of fairly obvious reasons why when you think about the psychology of learning. That this, in comparison to today, is a low salience form. It's often redundant. Today he walks to town. Today, it's redundant, it's overshadowed, it's not salient. It's actually a form of low contingency, cues a lot of different interpretations. It's not well attended, particularly if you come from a first language background which doesn't use inflections very much. So there are transfer, blocking, and interference effects. So I think that the psychology of learning can tell us things about the learnability of constructions. And this is the final type of construction which I'm going to consider today, and this is the type of construction which I'm going to consider in a fair bit of detail. So
today he walks to town.
I can play this again and again and again, because it was my son when he was 5 years old. He's now 22 years old, but it takes me right back. So today he walks to town.
Today he walks to town.
So I'm interested today in verb argument constructions. He walks to town being an example of a verb locative. And verb locatives having central meanings. And how do we learn that particular type of construction? And I'm going to be thinking about frequency, prototypicality of meaning, contingency, in the learnability of verb argument constructions. And for those of you, including Ava, who 20 years ago, maybe a little bit less, met once a month in Katie's tea room in Chester And it was the shared child psychologists and usage-based linguists from Bangor and Sheffield and Manchester and Liverpool. And we met once a month. And that's where I came to know of the work of Elena Leven and Mike Tomasello. And this is an illustration adapted from Mike Tomasello. 18 years ago it was done on overhead projector slides, but today we have the benefit of PowerPoint. Mike, I remember him in Grigornog, I think, using this example. And broadly what he was saying was, imagine a child at a supper table. One evening, a young child at a supper table, hearing someone say, put it on the table. And somebody coming in and doing that. What are they going to get from that? And imagine the next night, they hear, put it on the table. And the next night, put it on the table. And maybe by then, what they've got is a pretty unanalyzed put it on the table, which goes along with someone or something putting something, the salt, the plate, the butter, on the table. But a pretty routine occurrence, which is significant in the world, which catches attention. Yep, it has movement involved. Something that we want to describe in language, and language is conventionalized to talk about those sorts of important things. And maybe the next night they hear, put it on the desk, and put it in the bag, and put it on the bed, and put it in the trash, and put it in the fridge. And eventually they're starting to sort out the different types of L's, the different types of locative, where you can put things. Yep. And you can put them in, and you can put them on, but you're starting to abstract from that experience a more generic type of schema, put it locative. And then you might be hearing, set it on the table, run it at the road, and you might abstract over more and more and more experiences like that, generalized verb, it, locative, get me on my way, let me at the ball, moving towards a generalized verb-object locative. Someone or something is moving something to a new place or in a new direction. Yep. Abstracting this generalized schema from a conspiracy of all of the types of verbs that you hear in that construction, all of the types of objects, and all of the types of prepositions. So an abstract schemata comes from a conspiracy of interpreted, often item-based patterns. Yep. So, let's then think about this young girl thinking about novel words. Let me ask you about some novel words that you've not heard before. It mandooled across the ground. Can somebody tell me what mandooling is? Anyone? Movement, thank you. Yep. You might be thinking about skittering or rolling or walking or hopping, but I suspect some type of movement has been involved. Yep. How about the Garm spugged him the book? What's spugging? Transfer. It's some basic notion of transfer. You might be thinking giving or faxing maybe, but probably some lending. You're thinking about some sort of giving. Now, mandooling isn't a word in English, spugging isn't a word in English. How, therefore, we normally think that the verb is the driving force of the sentence, but you've not come upon these things before. So how come you have that central idea of giving? Well, the larger configurations of words carry meaning, as Adele Goldberg has persuaded me for sure. And when we're hearing something like, when young girl is hearing something like it mandooled across the ground, then the notion is that the sentence is parsed as a V across N construction. The Garm spugged him the book as a double object construction, a ditransitive construction. So We're learning somehow this girl is not looking up a word in a dictionary. She's not asking her mum what mandooling is. Maybe she is, but she's going to be able a lot of the time to interpret these words in context. How? Well, step one is analyzing the first sentence as a V across N, the second sentence as a ditransitive. And the next part of the process is waking up the conspiracy of all of the verbs that have been experienced in this particular construction, or all of the verbs that you've experienced in this particular construction, and coming out with the weighted average of their meanings. Yep. The weighted average of their meanings, weighted average depending on frequency of experience. You've heard a lot of gives in verb, object, object. You've heard rather fewer lens in verb, object, object. And you've heard far less nowadays faxes, faxed in verb, object, object. Yep. So, what affects learnability? Well, there's some semantic bootstrapping. Semantic categories guide form meaning correspondences. We need to wake up the conspiracy of all of those verbs and come up with their central tendencies. The syntactic bootstrapping, identify it as a V across N construction rather than a ditransitive. Frequency is going to be really important. Contingency is going to be really important. Some verbs can appear in lots of different constructions. They are fairly promiscuous. They don't really tell you what the construction is going to be. Other verbs are much more reliably associated with a construction. And frequency is going to be important. And Adele Goldberg first pointed us at Zipfian frequency distributions as being important, and I really believe it. And so these factors, from a psychological point of view, are going to be the factors which are important in the learnability of these constructions, and they're the factors which I'm going to try and look at today. So I'm going to think about the emergence of these constructions as a conspiracy of experiences. And here's another picture for you to try and take away with you, because I think it sort of conjures up the notion very well. I love these pictures. I got them from the internet. They're from an artist called Corinne Vionnet. And I think what's clever about them is that they appear to me to be the prototypical scenes, for example, of the Brandenburg Gate or Mount Fuji. But she's created these pictures by trawling the web, finding people's holiday snapshots, and glomming them together. Now, sure, she's doing a little bit of, well, we'll make them all the same size, but these prototypical views of the Brandenburg Gate come from a sum of people's snapshots. And what you can see, maybe, is some noise in the front here, where one tourist was walking in front at one point, and then a group of tourists was walking, and they wash out. And what you get at the end is the prototypical scene. Yeah? Now, I think this is really sweet for a number of reasons, and what I want you to associate with this picture is the notion that, you know, when people come to photograph the Brandenburg Gate, they could have taken the photograph from over here, or they could have taken it from over here, or they could have taken it from over here, or they could have taken it from over here, but in the main, they take it from here. And if you look at the pavement, you'll see it's warm there because everybody stands there to take that photograph. There is a sweet spot, which gives you the prototypical meaning or the prototypical scene, when you're visiting this site. So, prototypes, categories coming from a conspiracy of experiences, but at the same time, a conspiracy of experiences, frequency-biased experiences, but there's a sweet spot. Okay? Now let's think about the acquisition of verb argument constructions in those forms. So what I'm going to do is a three-part talk from now on. I'm going to talk about verb argument constructions in usage and the sort of corpus linguistic work that we've done to try and look at the typical usage experience of these constructions. And then I'm going to look at them in learning, and I'm going to tell you very briefly about some second language acquisition work we've done and some child language acquisition work that we've done. And then I'm going to talk about some processing experiments, both very conscious, deliberative processing and some automatic, ballistic processing experiments, all using these stimuli. Because I'm encouraged that when we discover something about the usage experience, that tells us something about learning, and I'm encouraged that it also tells us something about ease of processing. So here we go. So when we're interested in usage, we're going to be looking at those factors which I've described to you already. Frequency. This is the first most frequent word. Oh, look, it's really, really frequent. The second most frequent word, roughly half as frequent. The third most frequent word, roughly a third as frequent. And this is a Zipfian frequency distribution. Yeah. And if you log both axes, you get a straight line, and that tells you it's a power function. And power functions are interesting, and they're interesting from a complex adaptive systems point of view because they promote robustness. Power functions promote robustness. Oh, we're interested in robust language acquisition. Yeah? How is it that you've learnt your language from the people you've talked to? I've learnt my language from the people I've talked to, but somehow we can speak the same language. What gives us that robustness? Well, maybe it's robustness of experience. Yep? So, going to be interested in frequency distributions in usage, but we're also going to be interested in frequency, in prototypicality in semantic networks. Prototypicality of meaning. And these are the things which we're going to look at in usage. And this is the, I don't know what this is, a British National Corpus maybe, distribution of the verb lemmas in English. Be, have, do, will, ... hold, turn, like. This is the 50 most frequent verb lemmas in English. This is their real frequencies. And then you can take their ranks and you can log frequency. And here is be at, in this sample, 3.8 million, have 1.3 million, do 500,000, will, etc. And you can plot out those frequencies and it looks like this. Yep. The most frequent form takes the lion's share, the next most frequent form about half of that amount, etc. That's a Zipfian frequency distribution. And if you log both axes, you get roughly a straight line function. That's all of the verbs in English. I'm going to be concerned with sampling a subset of verbs with particular verb argument constructions and associated meanings. I'm going to be looking at verb argument constructions seeded on the lion's share taker go, that seeded on give, and that seeded on put. Yep. And I'm going to think about learning verb argument constructions like the verb locative, like the ditransitive, and like verb object locative. Okay? So we're sampling from a Zipfian frequency distribution. We're thinking about the acquisition of these different verb argument constructions and the conspiracy of experience. So what we did is we needed to come up with some empirical ways of identifying these verb argument constructions. And we went to the work of John Sinclair for this, a British corpus linguist, highly influential in really starting corpus linguistics. Trust the text, says John, look at the patterns. The CoBuild project, which was funded so that publishers, CogLinx, could come up with some decent usage-based grammars of English for second language learners. But John says, I want to know what usage is about. And so we used the CoBuild construction inventory, the grammar patterns of English. Here are a variety of grammar patterns of English where you can define them syntactically. Yep. And so we took those definitions and we went searching for verb argument constructions. And what we're going to do is we're going to search in a very big corpus, well, 100 million words, the British National Corpus, it was very big in its day. From 5,000 plus different speakers, we're going to search for particular patterns in a big corpus. We're going to look at what types of verbs appear in those constructions, what's their frequency distribution, how reliable are they in fitting into those particular constructions, what are their semantics. So here's one example. We searched for V across N, all of the instances of the V across noun phrase pattern in the British National Corpus. Here's one example. So we're using a lot of natural language processing to do this. Here's one example that we found. The clouds were scudding across the expanse of blue. Yep. So we found all of those examples, and we found nearly 5,000 tokens, 5,000 verbs that appeared in those patterns. There were roughly 800 types, verb types that appeared in those patterns. The most frequent verb in that pattern was come, followed by walk, followed by cut, followed by run, followed by spread. And if we order according to frequency, that's the list that we got. And it looks like that. So there's come appearing roughly 500 times in the corpus. There's walk 200 times, etc. So there is the frequency profile of the verbs that appear in this construction. And if you log both axes and you do a cumulative frequency distribution, then here's come and then cut. This is a random sample at each frequency band. So you're getting an idea of the most frequent down to the least frequent verbs that appear in this construction. Zipf-ian distribution, you can order by frequency, as we've done here. You can also order by contingency, with a measure of reliability of association, a contingency statistic like mutual information. And if you do that, then the highest contingency verbs which appear in this construction are scud, skitter, sprawl, flit, and emblazon. Mutual information prefers low-frequency forms. Yeah? So high association, low-frequency forms get high mutual information. And you can see, things don't scud, they scud across. Right? Things aren't emblazoned, they're emblazoned across. Yep. So you can search in a big corpus using a syntactic template to identify particular verb argument constructions. You can look at the verbs that appear in those particular argument constructions, and the first thing you find is that their frequency distributions are Zipf-ian. We're going to look at the types, their frequency, their contingency, their semantics. Here are 20 constructions that we've searched for. They're all Zipf-ian distributed. Yep. So I'm not cherry-picking here. Zipf-ian distributions pervade language. Now, that might be really boring. That might be really, really boring. It might be that Zip describes a pattern that appears in language, and here's some language, and there it applies. And here's some language, and there it applies. And here's some language, and there it applies. Maybe this is just, it's a random sample from a Zipf-ian distributed whole. But we find these consistent Zipf-ian frequency distributions, but we then compare the verbs that appear in this construction with the frequencies of verbs that appear in the language as a whole, and this construction is attracting different verbs from this construction, which is attracting different verbs from this construction. Yep. These are all Zipf-ian distributed, but they're different verbs. They're not random samples. What we find is that when you try to explain the frequency of verbs in this construction using the frequency of verbs in the language as a whole, there's still roughly 80% of the variance still to be explained. Yeah? Okay. So, We've looked at a variety of verb argument constructions in a large sample of usage. We've looked at their frequency distributions, their type token frequency distributions. We've looked at their contingencies. What we're now interested in is looking at their semantics. What's the semantics of the verbs that appear in these particular constructions? If you look in the, whoa, don't do that. If you look in the CoBuild verb patterns of English at the V about construction, they say, oh, actually there are different meaning groups in the V about construction. There's the generic motion, walk about, move about, run about, but there are also subgroups that somehow are associated. Well, we can think of them as sort of radial categories. There's a subgroup like thinking about, knowing about, worrying about, caring about. There are cognition verbs, where we're metaphorically moving about problem spaces. Or there are communication verbs, talking about, writing about, asking about, saying about. And we want to get at the meanings of the verbs that appear in these particular syntactically defined frames. And so how did we do that? Well, we tried to do it, they had done it in the CoBuild, in the CoBuild project by having skilled linguists and lexicographers looking at these things and saying, oh, there's this meaning group, there's that meaning group, there's the other. We needed to do this to scale, 100 million words, and we needed to do it automatically. So what did we do? Well, we used WordNet. George Miller's psycholinguistic database, an attempt at a psycholinguistically motivated dictionary. So words are associated not alphabetically, but words are associated in meaning groups. And WordNet is pretty much a tree. And things which are semantically associated are closer in the tree than things which are semantically distinct. So it might be animal, carnivore is an animal, dog is a carnivore, poodle is a dog, terrier is a dog, poodle and terrier are close together. Tool, hammer, claw hammer, is a tool, screwdriver is a tool close together, but tools and dogs long way apart. So we can take any verb that we find and we can look them up in VerbNet, and we can take all of the verbs which we found in these computer searches, syntactically defined verbs, we throw away their frequencies. We just say, think is a type that appears in this construction, know is a type that appears in this construction, hear is a type, and speak is a type, and talk is a type, and they're close in the network, and so we say they're close. You don't have to go far. But going and talking, that you have to go a bit further, and talking and knowing, you have to go too far for us to say it's related. So we take the verb types, we look them up in WordNet. If they're close, we say they're close, and if they're distant, we say they're distant and give them a 0. We make this little matrix of similarities. The similarities are there in WordNet. They're not influenced by the frequencies which we've been finding things by. And then we use social network statistics and network science packages to build semantic networks. Semantic networks for the meanings of these particular verb argument constructions. And here is, and I apologize for the quality of the slide, and I was going to do it looking these things up on our web, but it was too much of a gamble that everything would work. And so I've got a small movie here. This is the semantic network of V about N. So this is the semantic network of the verbs in the V about N construction. And I'm sorry it's so small. So we looked them up in our database of found forms. and we find these meanings. And I quite like this image because it feels a bit dynamic. This is how I feel about these things. But this is like a network, and you can see that, well, maybe you can see that some of these nodes have very big blobs, and some of them have very tiny blobs. And the size of the blob is the connectedness of that node. And there are some nodes in the middle, like go and move, which are connected to lots of other nodes in the network. They're central, they're prototypical. And there are other nodes which are out there on the periphery. And if you sort of grab hold of one of these big nodes and drag it, as you were seeing in the movie, then the whole network goes with it. And if you grab one of these nodes over here, then only this little local community goes with it. Now, you can't see this in detail, but this network here so this is V about N, and here are the goes and the moves. These are the hubs of the network. These are like the hubs of an airline network. Yep. Whether you're going from Podunk to Aberystwyth, you still go through the central network. You still go through Charles de Gaulle. Yep. So these are the central nodes, and these are more peripheral little meaning groups. Here's the about network, and here we've got, oh look, talk about, speak about, mutter about, complain about, protest about, grumble about, rave about, gossip about, chat about, enthuse about. There seems to be a very sensible local cluster of meanings there, but what I want to emphasize is that these meanings are untouched by human hand. I haven't selected these. Yeah? What's happened is we've gone into a big corpus of 100 million words. We've identified the verb types syntactically. We've then used WordNet to build these networks which are ignorant of frequency, and yet there are some nodes which have particular high degree or at the center of the network, and there are other nodes which are much more peripheral. You tend to get these little communities of meaning which make sense to us as cognitive linguistics, or they make sense to me as cognitive linguistics, as cognitive linguists. We can measure the properties of these semantic networks. We can measure network statistics like average clustering and degree centrality and things like that. And what we find is that, lo and behold, these semantic networks are small world networks. They have a characteristic pattern. A characteristic pattern which is of interest to people who are interested in robust systems. Yeah? And small word networks are connected much more than random networks would be, and they are connected because there are central nodes of high degree which tend to connect these communities. And those central nodes of high degree are the prototypical nodes in the network. Yep. So, we start with syntactic definitions of verb argument constructions. We find particular lexis which is attracted to those verb argument constructions. We find particular meanings that are associated with those verbs, and we find these particular distributions. And what we find for the verb argument constructions of the type verb locative, verb object locative, ditransitive that we've been looking at so far is the frequency distribution of the types occupying the verb island of each vac are Zipfian. The most frequent verb takes the lion's share. Vacs are selective in their verb form frequency. There's a high contingency of verbs and vacs typically, and vacs are coherent in their semantics. So what we've done is some corpus linguistics, informed by cognitive linguistics. We've thought about thought sound. We've thought about frequencies in our experience of sound patterns. And we've thought about frequency and centrality of our experience of meanings. And we've thought about how those relate. Bad pun, zipf, how those go together. because they relate according to two different Zipfian distributions. One is a Zipfian distribution of frequency, and the other is a Zipfian distribution of node degree in these small world networks. Lo and behold, as Adele Goldberg told us, the high-frequency forms in our experience are the prototypical meanings. Yeah? And as a psychologist, well, that would be lovely. Because if I have to learn a category, if you want to teach me a category, if you want to teach me about birds, show me the prototypical birds, and I'll learn about birds. Yep. Don't start me off with penguins and flamingos and ostriches. No thanks. Tell me about robins and thrushes and then I'm going to get an idea of the central tendency of birds. That's the psychology of categorization. Well, it looks like usage does that for us. Yep. The high frequency patterns in our experience tend to be the central meanings in our experience. So, I've got 14 minutes. Here we go. We're going to look at learning very, very quickly, and then we're going to look at processing very quickly. So, learning. The first studies we did on this was second language acquisition. We were interested in, well, let's go and have a look. Adele's done all of this lovely work, but small-scale work on child language acquisition in a few families. Let's see if it generalizes to second language acquisition. So we went to the biggest second language acquisition corpus we could find at the time. This is with Fernando Ferreira. We were doing it in about 2005. And we thought, oh, well, there's the European Science Foundation corpus that Wolfgang Klein and Perdue gathered, which was a corpus of people of a variety of first languages learning naturalistically a variety of second languages. It was a huge project in terms of effort. It was done in the early 80s, over about 5.5 years, in 5 different countries, and they were tracking individual learners over about a 30-month period. And what we thought was, well, let's look at second language acquisition of English from 7 individuals, 4 Italian first language individuals, 3 Punjabi speakers, economic migrants to England, learning English naturalistically, being interviewed over a 30-month period, every month or so. Let's take their data and let's reanalyze them for these verb argument constructions. And let's look at, in these interviews, what the native speakers, which examples of verb locative verb argument constructions the native speakers used, and what examples the learners used. Yep. So we're identifying these 7 learners, we're trying to find all of the examples of verb locative and trying to find the verbs that appear in verb locative. And here's a frequency distribution. Here are the native speakers, the interviewers. Go is the most frequent verb locative, followed by come, get, look, live. And here are the learners. Go, come, sit, look, get, live. You can see Zipfian frequency distributions and broadly the same lead verb in the native speakers as in the learners. And verb object locative put, yep, and ditransitive give. And here are the frequency distributions in the native speakers, which we're using as a sort of proxy for the sort of language that these learners might experience. Here are the frequency distributions of the learners, and if you know the frequency patterns of typical import, then you can predict correlations of 0.97, 0.9, 0.93, the verbs which the learners are going to be picking up on. And so in the second language acquisition corpus, it looked pretty much like the story that was there for first language acquisition. Zipf's law applies in the L2 import. The highest frequency exemplar within each FAC is prototypical in meaning. We had ratings of meaning prototypicality. Learner acquisition is seeded by the highest frequency prototypical exemplar. Here are our learners and the verbs they use in verb locative over the course of the project. Here is one verb which starts and takes the lion's share thereafter and is the central tendency of that verb locative construction, and it's go, followed by come, followed by, yeah. Okay? So there's a type token frequency distribution which is Zipfian. Prototypicality, contingency, we measure all of the contingencies and we see that the verbs are reliably associated with particular constructions. And we can explain most of the variance of the verbs that appear in those patterns using those three dimensions. And just because we were coming from a connectionist background, we had a little play at a little connectionist model of if we gave a connectionist model, a serial recurrent model of the type that Jeff Ellman used, sometimes for movement, sometimes for collocation. So a sort of vanilla type of serial recurrent network. And we trained up this network on the verb argument constructions, the verbs, the prepositions, the locatives in the learner experience. So we trained it up on the native speaker language. We trained up the network on the whole corpus of verb locatives, of verb object locatives, ditransitives. It learned over time which verbs were associated with which constructions. This picture you've already seen, which is the second language acquisition of verbs in those constructions. This is what the model learnt. Here are some verbs which it learnt very early, are highly associated with this network. Here are some verbs which never appear in that type of construction. And the correlation between what the dumb connectionist learning mechanism, the statistical learning mechanism, exposed to the type of input as characterized by the native speaker input. Anyway, the connectionist model, which was learning from the native speaker input, gave learning that emerged like this, and it looked pretty much like the real second language learner patterns of acquisition. There was a 0.77 correlation between the model and the people. Yep. So we did that with second language acquisition. Much more recently, we've tried to do it going back to first language acquisition. And this is work with Dave Ogden. So we've tried to go back to these same constructions, but now in first language acquisition, but doing the same sort of very idiographic, very idiographic, let's find as much as child-directed speech as we possibly can. Let's find as much child language as we possibly can. And let's try and analyze the typical patterns of input and the typical patterns of acquisition. And let's see how a generic verb object off construction might emerge from instances of usage, from particular instances of experience. And we've done this for 5 million words of child-directed speech and 2.5 million words of child language, pirating unashamedly all of the child language which child language researchers have deposited into Childus. But we've then used our same techniques to look at the typical patterns, the verbs in child-directed speech, the verbs in child language, but trying now to sort of ramp up the scale a bit. Do we find Zipfian patterns of verbs in verb object off in child-directed speech? Yes, we do. What are the types of verbs that appear in there? Are they just a random selection of verbs in the language? No, they're not. There's still 88% of variance to be left explained if you just know verb frequencies in the language. If you then look in the child language, do you find Zipf-ian frequency distributions? Yes, you do. If you look at acquisition profiles, averaging over all of these different kids, and sort of laying them out in mean length of utterance, what do they look like? Well, one verb takes the lion's share. If you know the child-directed speech, do you know the verbs that children use in that language? Yes, you do. So we've looked at verb-object-off, but what about verb-object-locative? What about the verb-object-offs, the verb-object-ons, the verb-object-unders? How do you get a generic verb-object-locative from patterns centered on different prepositions? And so we look at these things, and each of the prepositionally islanded constructions is Zipf-ian distributed, both in the CDS and in the child speech, and in the more abstract construction. And does child language follow child-directed speech? If we look on a construction by construction, logged frequency analysis, by heck, yes, it does. And Mike was very clever in his using put as the exemplar, in his overlay slides when he was making us think about these things, because put really, really, really is the high-frequency exemplar of the generic verb-object-locative. It takes the lion's share. Okay, so we've done that, and now I've got 4 minutes to do usage in mind. Let me give you just 2 little examples. Here's a series of experiments we've done with native speakers and with a variety of second language learners, and it was the simplest psychology experiment, the most fundamental psychology experiment we could think of. And it's a free association task. Freud onwards, free association task. So what we did was we got native speakers of English, undergraduates from the University of Michigan, and we gave them things like this: he blank of thee. These were the cues we wanted them to free associate to. Well, this is not going to get us anywhere, is it? Because this is a very highly frequent grammatical functor, and that's another very highly frequent grammatical functor, and that's the. We're surely not going to get any tight patterns. If we were doing corpus analysis, then we'd throw out these things because they'd be our stop list. But let's just think about what sort of verbs come to mind if we say, think of he blank of thee. And what we did was we gave these undergraduates a minute to come up with all of the verbs they can think of that might appear in that pattern. And here they are. And so this is a class of undergraduates. We've done it lots and lots of times now with lots of different populations in lots of different ways, but this is the sort of thing that you find. He blank of thee is associated with your average English speaker says he is of thee. But then 32 of our individuals said he thinks of, he knows of, he speaks of, he talks of, he hears of. It smells of, it reeks of. We have given people 3 of the most frequent verbs of the English language, generic he or she, blank of thee. And suddenly there is conformity where people say partake of, reek of, talk of. Tell me that grammar and lexis don't co-select. You give people 3 high-frequency functors in a particular pattern, and they reliably come up with words like smack, stink, smell, reek. These argument constructions, these frames, are associated in our minds with the conspiracy of all of the verbs that we've heard in these constructions, and bang, out they come. Yep. And if you know the frequencies of the verbs in those constructions, you know what verbs are going to come to mind. We have inside our heads the conspiracy of all of the verbs that we've heard in particular constructions. Yep. This is automatically woken up. Yep. We have learned these things implicitly, averaged over our experience of language usage. When I say implicitly, the tallying is done implicitly. The initial registration might be explicit, but that's a different matter. Yep. But we have inside our heads all of this experience, and this is what gives us our grammatical competence. And if we look at the semantic networks that we got from usage analyses, we can predict what verbs people are using. And over all of the constructions that we use in our experiments, because we'd already done our usage-based analyses in 100 million words, we can try and predict the verbs that come to mind in these variety of different frames from a variety of the usage-based statistics. And when we do that prediction, guess what factors are important? The factors that are important are the contingency of a verb in a construction. So these are multiple regression analyses over a wide variety of constructions and a wide variety of verbs, using usage statistics to predict the verbs that come to mind. What are the factors that are important? Contingency. How reliable is a verb associated with a particular construction? Independent of frequency. How often have you heard that verb in that particular construction? Independent of semantic prototypicality. Yep. When we're reading that frame, the verbs that tend to come to mind are those which are highly contingent, highly frequent, and semantically prototypical. Yep. And we believe that what's going on here is spreading activation. Okay, two more, so we've got independent effects of those things that we thought at the beginning might be driving learning, driving association, driving processing, and that's the sort of thing we find. I'm going to wrap up. Give me 3 minutes and we'll be there. We've done it with second language speakers. We've got speakers of L1s, which are also satellite framed, and they work pretty much like English speakers. We've got speakers of L1s, which are verb framed. And what we see then are deviations from the native speaker patterns, where the high-frequency exemplars are overused and underused the particular verbs of manner which English speakers tend to say, but the second language learners don't. So what we've got in second language acquisition are effects of usage, effects of first language acquisition, usage, and then second language acquisition usage. Yep. So a cognitive system which is first tuned to one way of thinking about language and then affected by second language acquisition. Okay, when we did these experiments about 5 years ago, people said, well, that's all very fine and dandy, but sit down for a minute and think about the verbs that might come to mind, is a very conscious strategy. Now, this could all be ad hoc categories. Yeah, very conscious deliberation, moving around a problem space. That's not really getting at the architecture of the processing system. So we've just since done all of these since we've done a lot of experiments, undergraduates down in the psychology labs, doing perceptual recognition, naming tasks, lexical decision tasks, tasks like, we show two-word sequences at threshold, and if they get it right, then we knock the exposure time down a bit, and if they get it wrong, we up the exposure time, and we titrate to the learners, and we see what are the characteristics of two-word sequences which people can perceive versus not perceive. Yeah? Or we do naming, say these things aloud as quickly as possible, or we do lexical decision. Look at these two-word sequences. If they're both words, hit one hand. If they're not both words, hit the other hand. Behave like yes, no, no, yes, yes. Yeah? So what you're doing is as quickly as possible, and we're going to measure your reaction time. Are these both words or are they not? This is based on Dave Meyer's work, semantic priming, spreading activation in networks. If the two words are semantically associated, like doctor and nurse, you say, yes, they're both words faster than if they're not semantically associated. Yep. So we do lexical decision, we do interposed lexical decision, so looking to see, is it just collocation or is it not just collocation? We do meaning judgment. So we have cohorts of 30 undergraduates down getting their psychology credits, volunteering to do these experiments for psychology credits. Down in the basement, we look at what predicts processing in these online ballistic automatic tasks. What predicts processing? We're giving them things which are high or low in verb frequency in the construction, contingency, semantic prototypicality. Across all of these experiments, recognition threshold, naming latency, lexical decision, meaning decision, etc. Just about across all of them, we have effects of frequency. That's where we came in. We also have effects of the frequency with which these verbs in usage are associated with these particular constructions. Across the board. Yep. Sometimes we get effects of semantic prototypicality. Sometimes we get effects of that contingency. It depends on the processing task. And we have a story that goes with it, whether or not this task is affected by spreading activation, unconscious meaning activation, or particular characteristics of that meaning in that place in that time. So we have a story. But the point I want to finish off with is that if you look at processing, then what you find is that this is ballistic processing now. This is not conscious, sit down and think about it. This is as fast as you can. Yep. But in as fast as you can, you get effects of frequency, you get effects of contingency, and you get effects of semantic prototypicality. So, to finish off, and thank you for your indulgence, if you're interested in any further reading, as Eva kindly explained, we have a monograph on this. If you're interested in the slides, write to me. The latest issue of Language Learning is a special issue on experimental, computational, and corpus-based approaches to language learning, trying to triangulate these different approaches. Couldn't have done any of this without lots and lots of work from a lot of very clever people. Uta Römer as a great corpus linguist, Matt O'Donnell as a natural language processor, Dave Ogden doing the child language work, lots of people over the years. What's the take-home message is, language usage is patterned. It's not random. Language is never, ever, ever random. It's highly patterned. It's patterned in ways that when you look at it as a psychologist might look at it, that might support learning. Language acquisition seems to be guided by this patterning. Language users have rich, implicit statistical knowledge of these patterns. Language processing is guided by this patterning. Usage-based learning. Yep. And I think it's exciting times to be investigating usage-based learning. Look at the range of backgrounds in this room, yet here we all are targeted on usage-based learning. Because now we're starting to get the techniques from cognitive linguistics, from cognitive science, from the psychology of learning, from psycholinguistics, from second language acquisition, from corpus linguistics, natural language processing, computational approaches, where we can start putting these pieces together, yep, in interesting ways. All right, that'll do. Thank you very much.
Thank you very much, Nick, for a breathtaking talk. I'm sure there'll be lots of questions and comments. Thomas.
Right, thank you very much for this fascinating talk about your work. Can I just ask you about one thing? You talked about language acquisition. You discussed about 200 examples. and you didn't walk about very much, and you didn't walk up the hill. But would all these instances of talk about, discuss about 50, and walk about be the same in your analysis? And is that then a construction, or is that a pattern? Because the pattern grammar is called pattern grammar because it looks at surface patterns. And I would argue that he talked about something is different from he walked about, because that's basically the position of any kind of locative. And discuss about 50 examples is a pre-modifier, the about is a pre-modifier of 50, but in a computation analysis it would all show up as being the same. How do you tackle this problem?
Right. It's a great question. As we started to search automatically for syntactically defined patterns, we decided we're going to search for these things using syntactic frameworks. And later on, we're going to be trying to analyze out their meanings. And if we start filtering at the very beginning, then as we're filtering, we're either going to be filtering using semantic interpretations, or we're going to be having more specific definitions of the syntactic frames, which may be there in the mind of the interpreter, may be there in the mind of the 18-month-old child, or they may not. So we decided at that point that what we should do is use patterns, to define these things, and then see later what meanings come out of them. And so you are right in your observation that what we have here is a pattern grammar type of analysis, which is not the same definition of a construction. There are many different types of construction grammar, and we each have our own favorite. But what we're trying to do here is say, let's look at the associations between syntactic pattern or lexicogrammar patterns, as defined by John Sinclair. And you might want to put more into your definitions than we did. But what we said was, we'll take the lot, and then we'll look at the meanings that come about. You said you have a lot of examples of about, but you didn't spend a lot of time walking about or moving about. I'm not going to start. I know how annoying it is to look at 50 slides and trying to find a particular slide, so I'm not going to do it. But we can talk afterwards. The lead exemplars in there were for about are walk about, move about. So they are the highest frequency forms. And they end up being the semantically central ones. So we had to make a decision. And what we wanted to do at that point was try to have, if you like, lexical patterns or sequential lexical patterns as our fishing net, and then identify the verbs and then deal with the semantics of what we find at that point. Now, your analyses of constructions may be richly informed by semantics or other aspects of syntax up front, but we had to make a decision. And if we put in the semantic filtering up front, then we'd be, to put it bluntly, disappearing up our own backside. If we use semantics at the beginning to find these things, then it would be no surprise that we find coherent semantics when we go and look at the verbs. So it was just a policy decision. That's how you go about it. Other people will define constructions in other ways. We wanted the blandest, empirically most rigorous, catch everything type of search, and then worry about what we found afterwards. Thanks.
More questions? Yes, please. Rachel?
First of all, before I ask the question, I wonder in what sense you use the word salient, in the sense of standing out, or instead in the sense of being listed in the mental lexicon?
Right, salience is one of the most slippery words that we have. From a psychologist's point of view, there are at least 3 different definitions of salience. Salience means standing out. Yeah? And things can stand out in different ways. They can stand out because they're loud or bright.
So this is the use that...
That is one use.
Okay.
Yeah? They can stand out because they're important to us. Mm-hmm. Yeah? Defined in our lexicon. Yeah? With heavy connotations. Mm-hmm. So they can be psychophysically salient, they can be psychologically salient, and they can also be unexpected. And so the other day we were talking about surprisal in the child language, predictive, learning from prediction, where you're used to the world now and you're expecting this to happen next and it doesn't. And you learn a lot from that, and that's salient too, because it's not expected in that situation. So there are at least 3 different aspects of salience. For what it's worth, a book is being published in about a month, edited by Susan Gass and colleagues, on salience in second language acquisition.
Okay, so now that I actually understand that this is the meaning that you actually assumed, standing out, there is some sort of contradiction between the factors that affect construction. So frequency, in a way, tones down salience, right? Because it has become so frequent, it is not salient. And
Mm-hmm.
something that is salient
Mm-hmm.
and, stands out is actually infrequent.
Yes.
So, is there any okay, and another question that is related to that, I don't know what to say just but I and my co-authors, we work on constructions, on negative constructions, and compare them to affirmative counterparts. And we recently ran a corpus-based search to find out whether the construction in the negative, like he's not the smartest person around, is more or less frequent than he is the smartest person around, that is, as opposed to the affirmative counterpart. And we found out that the affirmatives are always more frequent than the negatives, which are considered constructions. So frequency is also a kind of a lame excuse, even though I really appreciate this. And by the way, I have a book called, On Our Mind, and it is the graded salience hypothesis, in which I discuss salience in a different sense, so it doesn't really matter. But saliency that is registered or listed in the mental lexicon has to do with frequency. But here, frequency is not really a determinant factor. And salience, obviously, makes these constructions rather less frequent. So you have to deal with these inconsistencies or explain how you see the whole picture of all the factors that you listed.
Mm-hmm. Thank you for your question and observations. I think I would love to talk with you about the affirmative, negative, the relative frequencies, because I'm not sure I'm picking up on all of what you've got going. So let's have a chat about this. Salience is different at different stages of learning. Salience is all of the things which you've been talking about, but as we've spent our 10,000 hours on task learning our first language, so something which was highly salient at the beginning because it might have been noticeable is now highly salient because we're just used to it. It's a different type of salience. It's high frequency. Yeah? And we tend, as a native speaker, sometimes I may not hear something that you're saying, but I know you're saying it because I'm a native speaker too, and I'll fill it in. And most of those grammatical functors, which are the highest frequency forms in the language, are really slight in the input because we all know they're there and we don't have to emphasize them. So the things which are really salient to people who've spoken this language many, many years, are very different in presentation and in salience in presentation to a second language learner who's coming at it from the very beginning, or even a child who's coming at it from the very beginning. Some of those words, like what we were talking about, cake in the child language thing yesterday. Some words are highly salient because they're high frequency, they're big words, they're contentful words, they have lots of meanings. Things which we're highly attuned to in language processing are no longer particularly salient in the input, but they're salient in our interpretation of the input. Let's talk about. Thank you.
Thank you for a really fascinating talk. But of course, I'm going to challenge you on something, which is your first statement. So one could say language is patterned to support learning, or one could say learning has adapted to extract patterns from the input. And it reminds me of the argument that Morten Christensen and Nick Tater have been making. So I was wondering, how does your perspective relate to their argument? Is it the same? And if so, for those researchers within a usage-based account, what's the point of contention?
What's the point of contention?
If we all, as a psychologist, theory building works better when there's different frameworks or different hypotheses being proposed. And I was just wondering, at a broader perspective, what's the contrast here? What's the other perspective we should be considering?
Well, there's lots of other positions that are possible and have been stated at different times in studies of language as to whether or not language is shaped to the brain or the brain is shaped to language. I just want to talk to... we were both in the session with Vervi and Simon Kirby yesterday on co-evolution of languages. And it seemed to me implicit in all of Simon... Are you here, Simon? He's not here. That's a shame. But, okay. Anyway, I enjoyed your paper very much. But it seems implicit in all of that it's co-adaptation all of the way. Language has evolved to talk about the things which are important to us, embodied organisms in this physical world, in this social world, where we try and cooperate. Sure, as you were pointing out, different cultures will emphasize somewhat different things, and therefore their language will emphasize those things differentially. But at the same time, we have these types of senses with these types of typical mental representation, given normal upbringing in a normal environment, in the particular proportions which you had in your big eyes and small fingers. So that's the norm. Language evolves to talk about those things, and it's wonderful that our experiences and our language go together, so that if at times a language doesn't quite fit with how we're used to experiencing the world, well, your learners, they'll remember it in a slightly different way, and they'll use it in a slightly different way until it sort of clicks for them. So I don't want to say that, for sure, language is shaped to the brain, but the brain is also shaped to our experience and our experience of language. So I don't want to... I'm an emergentist. I believe in language as a complex adaptive system. I believe that you couldn't have language without the brain, you couldn't have language without the experience, you couldn't have language without the history of language usage, and it would be naive to try and prioritize one and say, oh, that's where language comes from. Yeah? Thank you.
One last question.
Andrius Kulikauskas of Vilnius Gediminas Technical University in Lithuania. I'm impressed by your approach, you know, and the Zipfian distributions that it shows in terms of what we're learning. But if the question is, what are we actually learning? There's some kind of learning taking place on that level. There's some kind of learning taking place on some kind of grammatical construction level. But I would think that what's missing is the real learning is activity. You know, that the whole purpose of language is to coordinate activity pragmatically, I'm presuming. So, for example, when you give the phrase, let me at the ball, and that's probably British English, not California English. So when I try to understand that, the crucial thing for me is to guess the activity. Maybe it means, like, as an athlete, I'm supposed to, you know, they're supposed to clear the way for me so that I could position myself. That's an activity. And when we learn, you know, through language use, I would think that's the number one thing that's becoming entrenched in our mind is the standardization of activities. So this is something that's completely ignored in linguistics. And in terms of language learning, it would have big consequences because, like you were saying about immersion, like if you're not a participant in language, then how could you, and if you're not thinking about activities, if you're not learning activities, then what kind of language learning are you going to have? It's just going to be, and also for child learning, the difference, like if a person already knows the activity, their learning of the language will be very different than a child who may not actually even have a concept of the activity. So what could be done to have linguistics more based on cataloging activity?
Sure. Great question. I am inspired, and I agree with you entirely. And since I've been in the 20 years I've spent in second language acquisition research, I have seen turf wars, I have seen battles within second language acquisition between generative linguists, cognitive psychologists, bilingualists, lots of different approaches to language. And what is really significant over that 20 years is that in second language acquisition, Vygotskians, socioculturalists, people like James Lantolf have been pushing the need for building social interaction, cooperation into our theories of second language acquisition. Acquisition from a textbook is totally different from acquisition from everyday life. And we need, to the degree that it has been called the social turn in second language acquisition, there has been a huge wave of acknowledgement in second language acquisition of that. In first language acquisition, well, hey, if it's usage-based linguistics, then for me it was Mike Tomasello. And what does Mike spend most of his time doing now? He is worried about humans as the cooperative primate rather than the competitive primate. Yeah? So most of his work now is on collaboration, communication. Child language acquisition takes place between individuals who love each other, who are devoting most of their life to cooperating and scaffolding. Yeah? Trying to understand language. I apologize. Today I've been counting things, counting bits of language, thinking about the psychology of learning, but you're quite right. What we need to do is add the social, communicative, collaborative, activity-based engagement to that whole learning as well. Thank you.
All right, I'm sure there are lots of questions, but unfortunately we've run out of time. Before, we're going to thank Nick in a moment, but please don't leave because the organizers would like to make some announcements. So first, let's thank Nick.